Delaware Tech, Chemistry 100, Chemistry 110, Organic Chemistry, Functional Groups. Functional groups are groups of atoms or molecules that add function to the molecule. Alkanes by themselves are fairly boring molecules, as I mentioned before. The only thing that you can usually do with most alkanes is set them on fire and produce heat or energy from them to do some useful work or to warm up someplace. Functional groups give chemical function to the molecules. So alkanes are not considered a functional group. They're considered the absence of functional groups. So functional groups are very varied. There are many different types of functional groups, and we're going to cover a handful in this module. They are similar to substituents. In fact, they can be substituents. They can be part of the main chain. They can be sticking out of the main chain. So very specific types of atoms have very specific types of chemical behavior. And we classify organic compounds by which functional groups, which groups of atoms in the right structural formation, are in which molecules. So if it has what we call an alcohol group, we call that molecule an alcohol. If it has an aromatic ring in that group, we call it an aromatic compound or an aromatic ring compound. And we'll talk about what those are. So some of the most common functional groups are going to be listed here. Alkenes and alkynes. Alkenes just means there's at least one carbon-carbon double bond. Only between carbons to call it an alkene. Remember, alkane, A-N-E, means no double bonds between the carbons. Alkene means at least one double bond between carbons. And alkyne means at least one triple bond between carbons. And these are easy to remember because ane, ene, and ine are in alphabetical order. A, E, and Y, 1, 2, and 3 types of bonds. So if it has all single bonds, that's an alkane. If it has even one double bond, it's an alkene. If it has even one triple bond, it's an alkyne. And yes, it can be both an alkene and alkyne, but it can never be an alkene and an alkane. Once it has a double bond, it's no longer an alkane. Once it has a triple bond, it's no longer an alkane. Aromatic rings, we'll talk about those a little bit more. Then we'll talk about some of the simpler functional groups, alcohols, ethers, and amines. Then we'll talk about a group of functional groups that all have a part of their functional group called a carbonyl. That is a C, a carbon, double bonded to an oxygen. And there are going to be 5 types we'll talk about. Aldehydes and ketones, carboxylic acids and esters, and you may have heard the term ester before, and amides. These 5 all contain a carbon double bonded to an oxygen. So look out for those. So let's start with alkenes and alkynes. Many carbon compounds have single bonds as well as double bonds as well as even triple bonds. Triple bonds are rare, but they do happen. So once it has a double bond, as I mentioned, it's an alkene. It stops being an alkyne. It stops being an alkane. It only needs one to be an alkene. If you put a triple bond in there, and triple bonds tend to be straight, linear, like are shown here, it's an alkyne. And yes, as I said, it can have both, and then those are called ene-ines or alkane alkenes. I'm sorry, alkene alkynes. So you can have double. Aromatic rings are many different types of structures, but for the purposes of this course, we're going to limit it to the 6-membered benzene ring. Don't call it benzene ring on a test, though. We'll call it an aromatic ring. And you can tell aromatic rings, at least the benzene type of aromatic ring, it'll be 6-sided, so it'll look like cyclohexane, but every other bond is double bond. So it's double bond, single bond, double bond, single bond. And that alternating structure is what helps make it an aromatic ring. So don't confuse it. If this only has one double bond in it, it's not aromatic. If it only has 2 double bonds in it, it is not aromatic. And certainly if it has no double bonds in it, it's not aromatic. It has to have 3 alternating double bonds in it to be aromatic. Alcohols are carbon compounds that have an OH on them, a hydroxide group. You've already learned about hydroxides in the inorganic portion when we were studying ionic compounds. But if you have an OH attached to a carbon and the carbon doesn't have other functional groups on it, it's just carbons and hydrogens, that is called an alcohol group. If that oxygen has another carbon on either side of it, we no longer call it an alcohol. It is now called an ether. So alcohols have one carbon on the oxygen, and that carbon can have any number of carbons on it. It can have 0, 1, 2, 3 carbons on it, but it has to have an OH to be an alcohol. If the O is flanked by carbons, it's an ether. Aldehydes and ketones both have this carbonyl group I mentioned before, and we pronounce this word carbonyl. It's a C double bonded O, and this also has another name, but it's used less often. It's called a keto group. You've probably heard of the keto diet. It's actually related to molecules that have this group in them. So aldehydes and ketones are very similar molecules. You have a carbonyl, a C double bond O, and the carbon in the middle, that carbon on the carbonyl, has two other bonds available to it. If one of them is a hydrogen, or both of them are a hydrogen, we call that an aldehyde. If they are both carbons, we call that a ketone. So shown at the top here, this molecule, and I've shown it in two different ways, a condensed form and a skeletal form. Under aldehyde, this is actually acid aldehyde. It's derived from acetic acid, and that's where it gets its name, acid aldehyde. The molecule at the bottom, the ketone here, is the most famous ketone of all. This is acetone, which I'm sure you've heard of, especially if you've ever used nail polish remover. This is the main component of nail polish remover because it dissolves a lot of organic molecules. This is acetone. It's a ketone. Carboxylic acids and esters are two more carbonyl-based functional groups. So they have a carbonyl or a keto group in them. And an acid looks a little bit like, this is a carboxylic acid, excuse me, you can't say just acid. Carboxylic acid has a hydroxyl group on it, which suggests it looks like an alcohol, but it's not an alcohol. Try to get my text to write here. Let's get that going. So it has what looks like an alcohol, but once it's attached to this carbonyl, it is no longer called an alcohol. It is a carboxylic acid. And if we add another carbon group to the other side of this oxygen, just like we did with the ether, but an ether with a carbonyl is now called an ester. So this is a carboxylic acid. It should say carboxylic acid here, if it's just the OH on the carbonyl. But if it's any carbon group on the oxygen here, it's an ester. And this could be one carbon, it could be branches of carbons, it could be a long chain of carbon, it could be an aromatic ring on the carbon. Okay, any carbon here that's attached to this oxygen, and the oxygen is attached to a carbonyl, instantly becomes an ester. And esters, many esters are actually quite fragrant and are used as artificial flavors because they're actually the natural flavors of a lot of fruits and sweet foods. So amines and amides. Amides are another carbonyl compound, but amines are not. So amine is just any organic molecule that has a nitrogen on it, and the nitrogen must be attached only to carbons or hydrogens. If it's just carbons or hydrogens, we call this an amine. But if we put a carbonyl next to this nitrogen, and it, like I said, doesn't matter if there are carbons on here or just hydrogens. This could be a carbon, this could be a hydrogen, it doesn't matter. Once you put that carbonyl, the amine is now called an amide. An amide can be pronounced amide, amide, amide. There are many pronunciations for this word. Any of them are acceptable. Amine is typically the way Americans pronounce this first word, but this one has many varieties that a lot of people use. So, to review the ones with and without carbonyls, of all the functional groups I've talked about, we actually have some parallels here between versions that have no carbonyl and ones that have carbonyl. Alkanes, for instance, are just simple hydrocarbons with no double bonds on them. But if you put a carbonyl on it at the end, the last carbon, it'll become an aldehyde. If you put it anywhere in the middle so that that carbonyl has a carbon on either side, that's a ketone. Alcohols, as I mentioned, are carbon compounds with an OH group on them. That OH is the alcohol group. And you can tell alcohols because they end in OL. If I have a carbonyl on it, it's no longer an alcohol, it's now a carboxylic acid. And you'll learn later the reason why it's called a carboxylic acid. It's carboxy, C, carbon and oxygen based, and it's an acid because it has a hydrogen that can be donated as an H plus ion, which we'll talk about when we get to the module on acids and bases. So you'll notice the last part of this is always C with 2 oxygens and a hydrogen, and sometimes that's written as CO2H or COOH, but that is your tip-off that you have a carboxylic acid. Oops, let me erase that. So if we look at ethers, ethers are just an oxygen flanked by 2 carbons, 1 carbon on either side. Oops, sorry. So if I put a carbon on either side of this ether, I'm having trouble with the notation here. That's a carbon around my oxygen. If I have a carbonyl on it, it's no longer an ether, it's now an ester. And people confuse these two words. It's very easy to confuse. They're spelled very similarly, so please be careful. Ether, no carbonyl, ester, carbonyl. And amine, as I mentioned, it's a nitrogen with either carbons or hydrogens attached. Here I have a carbon, but I could have had a nitrogen. As long as there's at least 1 carbon on the nitrogen, that's an amine. But the second I put a carbonyl, it's no longer an amine. It's an amide, amide. Any one of those is the correct pronunciation. So make sure you understand this chart here and get comfortable with the ones with and without carbonyls. So IUPAC has very specific rules for how to name functional groups. You don't have to know a lot of detail for this course, but just to remind you, any alcohol tends to end in OL. You know about methanol, ethanol. Ethanol is the one you can drink. Methanol is the one that comes from wood and will cause you to go blind and kill you. Isopropanol, also known as rubbing alcohol. Those all end in OL. Aldehydes tend to end in AL, as in aldehyde. So we have aldehydes that end in AL. Sometimes they end in the word aldehyde or something like aldehyde. Carboxylic acids will end in the suffix oic, OIC, acid. So not all of them, but many of them do. So we have butanoic acid, pentanoic acid. Sometimes the O is not there, as in butyric acid, or even acetic acid, which is the 2-carbon version. So, but it always ends in ic acid. Most often we'll have an O in there as well. So treat these groups as branches because these tend to stick out from the chains or at the end. The aldehydes and the acids are at the end of chains. The alcohol can be at the end or sticking out from the chain. So here are some drugs you've seen before in a previous video module: aspirin, naproxen, ibuprofen, and Lipitor. Let's look for some functional groups. So you'll notice all of them have aromatic rings. Sometimes the rings are double rings, as in naproxen, also called naproxen. Sometimes they're single rings in all the others. So aromatic rings are very common in drugs. We also have esters. You'll notice the ester is recognized because you have a carbonyl attached to an oxygen, and that oxygen is attached to another carbon. In this case, in aspirin, the carbon is part of the aromatic ring. Alcohols are OH groups sticking out from a carbon. So there are 2 here shown in Lipitor. Ethers, you're going to look for an oxygen that just has carbons on it and nothing else. Just a carbon on either side, and there's nothing special about the carbons in terms of other types of atoms like oxygens or nitrogens attached. So this is an ester in naproxen. It happens to be attached to an aromatic ring, but it's still an ether, but it's still attached, still part, excuse me, it's still an ether even though it's attached to an aromatic ring. Shown in Lipitor, right in the middle, is an amine. It's an amine because it's a nitrogen, and in this case, this nitrogen is attached to 3 carbons. Amines can be attached to 1 carbon, 2 carbons, 3 carbons, and even 4 carbons if there's a positive charge on it. They're actually called primary amines if it's only 1 carbon, secondary amines if it's 2 carbons, tertiary amines if it's 3 carbons, and if it has a positive charge because there are 4 carbons on it, those are called a quaternary amine, quart meaning 4. You're not responsible for those types of amines, just be able to recognize an amine. Carboxylic acids are very common in drugs, and in fact, every one of these drugs has carboxylic acid. You see in aspirin, it's shown at the top. You see that carbonyl with an OH. If we look at naproxen, it's over on the right, another carbonyl with an OH. And Lipitor, and over on the right, a carbonyl with an OH, and ibuprofen, another carboxylic acid on the right. We also have an amide function, or amide function. In Lipitor, you'll see there's a nitrogen attached to a carbonyl. Once that nitrogen is attached to the carbonyl, doesn't matter what's on the nitrogen, that is an amide, or an amide, or an amide. So here is a fake molecule I made up that has one of all the functional groups you've learned except for halo groups. I didn't include fluorine, chlorine, bromine, iodine. Those are halo groups. You can consider them functional groups. Some people do, some people don't. For the purpose of this course, you can count them as functional groups. But alkanes are not functional groups, so it's not listed here. Remember, alkane is the absence of all these other things on it, including heteroatoms, double bonds, and triple bonds. So let's see if you can find the alkene. That's the first one. Well, if you look over on the right, you see that double bond. That's an alkene. Alkyne, you're looking for a triple bond. And there's only one triple bond in this molecule over on the far left. And they're very easy to spot. They tend to be linear. The atoms around them tend to be in a straight line. They're easy to see the triple line. Aromatic ring, also very easy to find, right in the center of this molecule. Alcohol. So now you're looking for an OH group. And look at the top. You see the OH group sticking out from a carbon in that 6-membered ring. Now that ring that the OH is on is not aromatic, you'll notice. It's just the 6-membered ring. It's a cyclohexane ring, as a matter of fact. Ether. So now you're looking for an oxygen that has carbons on either side, and there's nothing special about the carbon. There's no carbonyls on the oxygen. And there's one of those. It's right over here. Now you could argue it's not quite an ether because that SH is sticking out from the carbon, but that's okay. The SH is a group that we don't talk about in some classes. I included it just in case, but right now we'll ignore the SH. It's called a thiol group. Thiol just means sulfur containing. So the ether, you're looking for an oxygen with carbons on the either side without a carbonyl. The next one is F, amine. So now you're looking for a nitrogen that's attached to carbons but not with carbonyls on them. And there are 2 different nitrogens in this molecule. One is a nitrogen attached to a carbonyl, and one is not. And the one that is not is right there. So that's an amine. Aldehyde. Aldehydes tend to be sticking out from things because they are carbonyls with a single hydrogen on them. So you're going to look for that. Take a look around. So you're going to look for all the carbonyls, the C double bond O's. And there's only one place where there's a hydrogen on it. It's over there on the right. Ketone is just like a carbonyl. I'm sorry, it has a carbonyl. It's just like an aldehyde, but it has carbons on either side of it. So remember, it's one of the simpler carbonyl compounds. So you're looking for a carbonyl that just has carbons on either side, not oxygens or nitrogens or sulfurs on it. And while there are quite a few carbonyls in this compound, all of them have other things on them besides 2 carbons. There's one that has just 2 carbons. That's right here where I've labeled H. Carboxylic acid, again, you're looking at the ends of things. They don't tend to be in the middle of a molecule. They tend to be sticking out from it. You're looking for a carbonyl with an OH, and there it is right there in the bottom left. Ester, You're again looking for a carbonyl with an oxygen, but now that oxygen must be attached to another carbon. So take a look around. And do you see it? It's over in the bottom right-hand corner of the molecule. There's our ester. That's a carbonyl with an oxygen, and the oxygen is attached to another carbon. And an amide or amide, or let's see if you can find that. You're going to look for a nitrogen next to a carbonyl. And there are only two nitrogens. We've already labeled one of them. The other one is right here. That's your amide or amide. The thiol I mentioned is the SH group. And a thioether is just like an ether, but it has a sulfur instead of the oxygen in the middle. You don't need to know those for Chem 100, so just make sure you know the other ones in here. And with that, we'll stop.